Okay, welcome back, Eden Prairie students, Honor Chem kids. I just want to give you guys an opportunity to do a little bit of practice with what you learned in the first video, sig figs part 1, and identifying the number of sig figs in a measurement. So what I'd like for you guys to do is to pause this video and write down in your notes the number and the number of sig figs that would be for each measurement listed. And then once you're done, you can resume the video and I will have the answers there. So please hit pause and do this work now. All right, well, welcome back, and hopefully you're have written down your notes on this and the number of sig figs that are with each measurement. So the first one we're looking at, all non-zeros, so the number of sig figs is 3. For B, you have a decimal point. You do have a trailing 0, but there's a decimal point, so that means this is the guessing digit. So there are 4 sig figs, because remember, the significant figure includes everything you know for certain plus that guessing digit. Here you have a trailing 0 and there is no decimal point, so that means the number of sig figs is 2. Here you have leading zeros, they are never significant, and you have captive zeros, which are significant. So we don't count these, but we're going to count all of these. So this would be 4. And the same thing again, we have leading zeros and we have trailing zeros. These are not significant. The trailing zeros are, so there's 1, 2, 3, 4, 5. When you have 30 students, that means even though there's a 0 there, it's 2 because you counted them. So remember, when you count something, everything you count is significant. It doesn't matter if it ends in a 0. Anything in front of a times 10 is significant, so this is 3, and this would be 3 as well. So you have your significant digits here. One thing that kind of comes up, and I just want to make sure that you guys are aware of, if you had something like 910 and you want to indicate that this is the guessing digit, you could put a decimal place right there. If you have 910 and you want to indicate that this is the guessing digit, sometimes scientists just would even just underline that, or you could put this in scientific notation. So this would be the same, and we're doing meters here, so these are all in meters. So all of those, these two pieces right here would be exactly the same. The 910 expressing only 2 significant digits. So that is also options for that part when you're dealing with a 0, and we have to also know that it's kind of acting as a placeholder. So now what I want to get into is, what do we do when we have to do a mathematical operation like multiply or divide or add and subtract? Because we do have to multiply and divide and add and subtract our measurements in chemistry. So there are some rules for this as well. The first we're going to do is, I think, the easier of the two. It's multiplying and dividing. And the answer that you are going to report has the same significant figures as the factor that has the least sig figs. So we're going to do an example of that. And I have 2 examples here. So again, the answer has the same significant figures as the factor with the least sig figs. So if I take something like 2.8723 and I multiply it times 1.6, this number has 5 significant figures. This number, 1.6, has 2 significant figures. My calculator right here, this is what the calculator spews out, but I can't report all of that. So I can only report 2 sig figs because this is the factor that is limiting what I can report, which would be 4.6. Here you've got a factor that has 3 significant figures. Remember, the trailing zeros are significant because there is a decimal point. You have a factor that has 4 sig figs. When you do this in your calculator, will say this. You can't report all of that. You can only report up to 3 sig figs because of this factor, and you end up with 35.7. So multiplying and dividing, it's pretty easy. You are multiplying or dividing. You look at the factor that has the least number of sig figs, and that's how many sig figs you report. Where it gets interesting is when we are adding and subtracting. When we're adding and subtracting, the answer has the same decimal place as the factor with the least decimal places. So that's the new thing that you're looking at. And when you're doing this kind of work, I recommend that you go vertical, okay? You do the math the old-fashioned way where you kind of stack it all up on each other. And you'll notice here that this term is in the hundreds place, this term is in the tens place, and this term is in the thousands place. And what you can do when you're going vertical is that allows you to just kind of, see if I can do this with my marker pretty well. You can kind of put a line there, and that would limit how far out you can go. So the answer for this that you should report is 3,760. Now notice it's 0.9 because here your calculator says 0.898. And then in that case you would round because it should be 3,760.9. So what I would like you guys to do right now is I'd like for you to pause again, and I want you to carry out these calculations and express the correct number of significant digits. So you should go ahead and do that right now. Okay, welcome back. So you carried out these calculations, and when you do this math, and again, you could go vertical, so I'm going to go, oops, I'm going to make sure my marker's on, 5.4, oops, something weird's going on here. Let's see if I can go back to a different color. We're going to do this, just kind of off. Here we go. Okay, so 5, oh, now we're in red. We're going to deal with it. 5.44. And then I'm going to subtract, I know how it is, it's my orientation of my pen, 5.34103, and again, this is all in meters. When you do that, are you noticing that you can't go past the hundreds place? So this math would be 0.09, and then you'd have 897 here because it thinks this is all zeros, and the answer would be in meters. What you should report is just 2 sig figs. Since you have that 9 and the 8, this becomes 0.10 meters, and that's what you would report. Did you guys get that? Look at the second one. 5.44 plus 0.00075. When you put that in your calculator, you will notice, here I'm going to just line these up here, 0.0075. Are you guys getting what's going to happen here? When we add these together, I'm going to get 5.44075 meters, and look at that. This is so small of a measurement compared to the confidence in the 5.44, it is insignificant. So what you should be reporting is 5.44 meters. This is true. This is not a lie. Get used to it, okay? Here we've got a multiplication of something that has a density 2.4 grams per milliliter times 15.82. When you do this in your calculator, it says it's 37.968 grams. You can only report 2 sig figs, so you're going to report 38 grams. Notice in here the units cancel of milliliters, and so the answer should only be in grams. So in your homework tonight, there is going to be some practice problems with mathematical operations with significant digits, as well as identifying significant digits. I strongly suggest you do them and practice. Where it can get a little tricky is when we're given mixed operations. And with mixed operations, you would want to do what's in parentheses first, just like those rules say. So in this example, they had the 0.108 minus the 0.100. That's going to in turn give you a 0.008. Notice there's one sig fig in that number, and then you're going to multiply it by this fraction, in essence. Because of this one sig fig, you can only report one sig fig. So you'll want to do this yourself. I'm going to ask you guys to pause this and try this problem right here yourself. How many sig figs would you report? Pause this and come back once you've done it, and then you can see if you're right. All right, welcome back. Well, did you notice that this is a 2 sig fig? You get 0.89 when you do this mathematical operation times the 737. So that would give you something like 660. And again, I don't have a unit in here, but whatever the unit would be, let's just say it's meters. It would be 2 sig figs because of this term. So hopefully you got that correct as well, okay? Your book will also talk a little bit about the rounding rules, so I just kind of wanted to point that out to you as well too. There's just a little weird thing that happens when you have a 5. If you end in a 5, and like this example right here, you've got 4.635 kilograms, and you have to round that to 3 significant digits. There is this strange piece that if you always round it up, you'd be adding a little bit of bias. So your book follows these rules of you round up on odds. So the 3 in front of the 5 is an odd number, so you're going to round up to 4.64. But if you have an even number in front of the 5, you would stay even. And just keep this at 78.6. So that's the only reason I wanted to kind of point this out to you in case you get and you notice this. It is something that's actually used in higher college level courses, or if you go as an analyst, as an analytical chemist, there's some of these rounding rules that you do have to pay attention to. But I don't really care. You can always round up on 5s in my class, and I know also in Miss Herring's, she would be okay with that too. But it's in the textbook, so I just wanted to point that out to you. And then finally, the last piece I want to just talk about really briefly is your book talks about direct proportions and indirect proportions. We're hoping you could look at a data set and you can say, oh wow, this is going up, the mass is going up, the volume is going up. That's a direct relationship, and a graph would look very similar to this. Same thing here is that if you notice this is an indirect relationship, the pressure's going up and the volume is going down, and this graph has a indirect relationship, which you can kind of see here with the downward sloping exponential function line. So those would be just terms that we're hoping that you remember as well and that you can apply if you see that in data sets. So that's the end of the significant figure lesson. I recommend doing the homework as assigned in your calendar, and we wish you luck. Hope to see you soon. Good luck.